Today we're going to be looking at trapezoids and kites. So theorem 615 states that the base angles of an isosceles trapezoid are congruent. So here are the bases, because they're parallel. So our base angles are congruent. So that means these two base angles are congruent, and these two base angles are also congruent. Theorem 616 states that the diagonals of an isosceles trapezoid are congruent. So we have if we label our trapezoid A, B, C, D, the diagonal AC is congruent to diagonal BD. So in example 1, we want to find the angle measure in the trapezoid. So trapezoid ABCD is an isosceles trapezoid with bases AB and CD. So since we know that, we also know that their base angles are congruent. We know the measure of angle C is 67 degrees. So that means the measure of angle D also has to equal 67 degrees because these are base angles. So to find angle A, we know that these two are supplementary angles. They add up to be 180 degrees because they're same side interior angles. So if we take 180 and we subtract 67, we end up with 113. So we know the measure of angle A is 113 degrees. And since we know this other base angle is also congruent, we also know the measure of angle B also equals 113 degrees. So now let's look at example 2. So we have an isosceles trapezoid TRAP. We know that TA, which is a diagonal, is 5x plus 18. We know that RP, our other diagonal, is 2x plus 30. We want to find the value of x as well as the length of TA. So since we're working with the diagonals, we know based off of theorem 616 the diagonals are congruent. So we know that TA, which is 5x plus 18, is congruent to 2x plus 30. So we can solve both sides for x. So we have 3x plus 18 equals 30. Subtract 18, so 3x equals 12. Divide both sides by 3, so x equals 4. So now we can use that to find the length of TA. So we know TA equals 5x plus 18. And since we just solved for x, which is 4, we can plug that into our expressions. We have 20 plus 18. So we know the length of TA equals 38. And since we know that RP is also congruent, we know that RP is 38 as well. Alright, so now let's look at our kite. We know theorem 617 states that the diagonals of a kite are perpendicular. So when we create our diagonals, they're perpendicular. Some other properties of kites, we have one pair of opposite angles are congruent. So those are congruent, and we know they're congruent. They're the two angles formed by the sides that are not congruent to each other, because we know that our adjacent sides are congruent. And another property is a diagonal bisects the two angles formed by the congruent sides. So an angle formed by the two congruent sides, so this diagonal is being bisected, so we know these two angles are congruent, and these two angles up here are also congruent to each other. So let's find the measure of our of our numbered angles. So we need to find the measure of angle 1, which based off of our theorem, we have our diagonal that's bisecting the angles that are formed by our congruent sides. So angle 1 also equals 39 degrees. The measure of angle 2 is formed by our two diagonals, and we know that the two diagonals are perpendicular, so angle 2 is 90 degrees. So then we need to find the measure of angle 3. So if this angle is also 90 degrees, we have a triangle formed at the top of our kite. So if we take 39 and we add 90, we end up with 129. Remember, three angles in a triangle add up to be 180 degrees. So if we take the 129 and we subtract it from 180, we end up with 51 degrees for angle 1. So now we want to find angle measures in this kite. So we have the measure of angle IKS, which is 34 degrees. And we have the measure of ETK is 24 degrees. So we want to find the measure of angle EIK, so we want to find this angle. ESK, so we want to find the measure of this angle. And the measure of angle ETI, so this angle down here. So let's start by finding the measure of angle ETI. So the measure of angle ETI, well, since this is our diagonal that's bisecting the two congruent sides, we know this is 24 degrees. So the whole angle is 48 degrees. So now if we look at the measure of angle ESK, it's 90 degrees because it's where our two diagonals bisect, and we know that they bisect, where they intersect, and we know that they intersect and are perpendicular. So then to find the measure of angle 1, I know I have my triangle, so I know I have 90 plus 34, which equals 124. So then from here, knowing the properties of our triangle, that three angles in a triangle add up to be 180 degrees. When we subtract 124, we end up with 56. So the measure of angle EIK equals 56 degrees.